In this video, we're going to learn things about additions to organic molecules. We learned about hydrocarbons in a previous video, and we learned how to name them. In this video, we're going to take hydrocarbons and somewhat do attachments to them. If the analogy to basically like a vacuum, where a vacuum now has different attachments, and each attachment is used to serve a different function. And that's what functional groups are to hydrocarbons. They each serve a different function because of different properties they possess, such as polarity and the connections that they can then do with other molecules. So today we're going to walk you through how to recognize them and how to name them. So here's a little chart that has the name of the functional group. That's more of its formal name. We also have what might be called its class. It's a nickname. So I'm going to give you both of them. I'll write the nickname underneath them. So for example, the hydroxyl group is the formal name to the functional group or the attachment. Its common name to any molecule that possesses these are the alcohols. So if you see a molecule that has the OH, that's its recognition of this functional group. The R is a variable. It somewhat stands for like the rest of the molecule, and often it's the hydrocarbon. And that hydrocarbon could have one carbon, it could have two, it can have three. Any of the prefixes that we somewhat learned in a previous video would be fair game to be added at this point. So I'm giving you one example to the right here. This would be for the variable. That would be the R. They're not drawing the rest of the carbons. It's just, this is the most important. That's the attachment. That's the rest of the vacuum that they don't really need to draw each time. So here's an example. I'm drawing a 2-carbon connection. You should, from a previous video, recognize the prefix for a 2-carbon connection, which is F. So the naming of this molecule does have the prefix F to it. Because the connection between the hydrocarbons are the alkanes, the next two letters indicate that you have a single connection. You could start changing these. We're not going to do that in this intro class. We're never going to have double bonds in there. If there were double bonds, hopefully you can somewhat predict that the changing of a letter from an A to an E would be visible, but we're not doing that this year, so don't worry about it. I will always give you single connections. From there, the ending for any molecule that has this functional group is the OL. And somewhat see it between the OL there, the OL there. They have some naming schemes to make it a little bit easier for you. So the name of this molecule is ethanol. But location is also important. So what they follow is the same rules of hydrocarbon branching and naming systems where the numbers are used. This system includes the lower number. So for this case, don't always go left to right, even though it's the second carbon from the left. If you reverse the numbering scheme, this is still the first carbon. So technically, we could write this as 1 ethanol. Given the fact that there's only 2 carbons in this prefix, there is no other option than to have 1, because counting from left to right or right to left. The next one, we've already done methyl. We've named them, so I'm not going to rehash that. That was in a previous video entitled Branched Hydrocarbons. But technically, those are functional groups. They add to the hydrocarbon chain. The next one is the carbonyl, and there's actually 2 forms or 2 classes of types of molecules under this category. There are molecules called the aldehydes, and we'll talk about them first. The aldehydes are the functional group, if you recognize it's a double bonded oxygen, just that, just one double bonded oxygen. But for an aldehyde, the double bonded oxygen is on N carbon. So this example right here is our example of the aldehyde common, or class name. Therefore, we have to name it specifically because it's an aldehyde. And here we have the prefix. Again, I'm keeping it consistent for reasons why in class you would understand. When you have 2 carbons, the prefix, I don't have enough room to do all this, so I'm going to erase that original. I'll somewhat even put the new name for this red up there. Prefix is going to, once again, be F. Prefix F, the AN because it's a single connection, but because this is an aldehyde, we have to recognize in the name that it doesn't have an OH, it has a double bonded O, so they added to an AL ending, somewhat corresponding to the aldehyde, so you can see that connection. Because it's always on the end, technically you're always going to have a 1. because the N carbon is always going to be the number 1 carbon. So this is 1-ethanal. As opposed to the second category of carbonyl group known as the ketones. It is still the same connection. It's a double bonded oxygen, but in this case, the double bonded oxygen is on an inside carbon. Not necessarily the middle, it doesn't have to be on the middle, but it's not on the end. So to name this type of molecule, you'll recognize that the prefix has to change due to the fact that there has to be at least 3 carbons. If you want an inside carbon, you have to have 3. And so this would be a prop prefix. The connections between all the carbons are single bonded, so it's an AN. And the suffix they put on it is ONE for the ONE suffix there. So you can see there's always a connection between the class or functional group name and the naming of the molecule. Because the connection can be somewhere in the inside, there is a number always associated with naming ketones. So this would be 2-propanone. If you elongate the hydrocarbon, you're going to have more prefix, such as butanone, pentanone, and the location always has to be indicated. A ketone can never start with 1 because that would insinuate that the functional group is on the N carbon, which then transitions it to the other class. So that's a little trickier one. Just pay attention to location. The fourth one on this chart is the carboxyl group. And the carboxyl group are commonly referred to as the acid group or the carboxylic acid. That would be where you have a double bonded oxygen, which is basically what the previous functional group is, and an OH group. So it's somewhat a hybrid between the hydroxyl group and the carbonyl group, all off of 1 carbon. It gets its own names, the carboxylic acid. This always has to be on the N carbon because of the sheer number of bonds it takes to build this functional group. You can see that it takes the double bonded oxygen and a single bonded oxygen. That's 3 bonds. Carbon only has 4 to do. So you can't put that on an inside carbon. There wouldn't be enough bonds for it to latch on to 2 more carbons. So this is always going to be on the end. The naming for this molecule, this would be prefix F, AN because it still has that single bond there, and they end it with oic acid. So oic acid, the name acid is in there because it is the acid group. So you have ethanoic technically. Once again, if you want to put a 1 in front of it, feel free to do so. It always has to be on the end. The next group is the amino functional group. Don't really change too much of its name when you go to its class name, the amines as they are known. For this, the name comes directly from the functional group itself. Where all of these were suffix endings based on the functional group, this is actually one where you put it in the prefix. I'll show you what that means in a second. This would be the name 1-amino, hence the name of the functional group, the amino group, followed by really the full name of the hydrocarbon it's connected to. So 1-amino-ethane. The location of the amino group can really be anywhere because this is a small ethane. It has to be on the end, but I could have made this a hexane and put the amino group on any one of the carbons, recognizing that you once again have to count the carbons from the lowest number. So that would be an example of the amino group. The next one is the phosphate group. We're not going to name this. You don't need to know how to name this one, but just recognize the phosphate group is an interior phosphorus with these 4 oxygens that surround it. So that's a phosphate group. It should be easy given the fact that it's the only functional group that you need to know that has the phosphorus in it. So it is the phosphate. The final group are the sulfhydryl. The common name to these, or this group, they are referred to as the thiols. And the naming of this is very similar to that of the aminos, where you put it as a prefix. So this would be 1-thiol, and then, sorry, I'm going to run out of room, so I'll put ethane down here. This should all be one word. I apologize. So 1-thiol-ethane. So it's a prefix as opposed to a suffix. So the amino group and the sulfhydryl groups are similarly named. It's just, once you hear one name, which I've given you an example of all of them, you should be able to change. The only thing that you would have to recognize is its number. Just like the amino group, the thiols can be on any carbon. It doesn't have to be on an inside. It doesn't have to be on the end. It can be anywhere as long as there is a carbon on the hydrocarbon. And then the prefixes. So it's learning one name and just adjusting from there, which I think should be easy for you to do. If you have any questions, please let me know. But those would be the functional groups that we're going to talk about all year long. So you might have to recognize these in future molecules when we start talking about, processes of the cell during photosynthesis, during the process of things that make up your cells. We will discuss these really the entire year. So hopefully it's something that sticks with you.